we need to find the derivative or sine inverse of 3x minus 4x cubed with respect to x. So let's begin by assuming y to be equals to sine inverse of 3x minus 4x cubed. That means we have to find out the value of dy over dx, or derivative of y with respect to x. So let's label this as equation number 1. Now what we'll do, we'll need to simplify the sine inverse of 3x minus 4x cubed using a trigonometric transformation. Here we are going to suppose x equals to sine theta. So if we substitute x with sine theta, then 3x minus 4x cubed, this will become equivalent to 3 times sine theta minus 4 times sine cubed theta. Now 3 times sine theta minus 4 sine cubed theta, this is an identity which is sine of 3 theta. So that means when we expand sine of 3 theta, we should get 3 sine theta minus 4 sine cubed theta. So that means our equation number 1 will become y equals to sine inverse of sine theta. Now we know that sine inverse of sine 3 theta will be equals to 3 theta. Now in place of theta, what we'll do, we will, since we are given x equals to sine theta, so this means that theta must be equals to sine inverse of x. So that means we have y equals to 3 times sine inverse of x. So this is the simplified form of equation number 1. In a sense, we can say the sine inverse of 3x minus 4x cubed is equivalent to 3 times sine inverse of x. Now we can easily find out the value of dy over dx, which will be equals to 3 times derivative with respect to x of the inverse sine function. So this is a standard formula which is given by 1 over square root of 1 minus x squared. So here 3 is multiplied to the 1 in the numerator. So this is the value of the derivative of sine inverse of 3x minus 4x cubed with respect to x. Let's move on to the second problem. We have to differentiate cosine inverse of 4x cubed minus 3x. So let's begin by assuming y to be equals to cosine inverse of 4x cubed minus 3x. So what we'll do, we'll do a trigonometric transformation here. For that, we are going to suppose that if x be equals to cosine of theta, then this implies 4x cubed minus 3x will become equals to 4 times cosine cubed theta minus 3 times cosine theta. Now this is a trigonometric identity and it's an expansion of cosine of 3 theta. So that means our function y becomes equals to cosine inverse of, so in place of 4x cubed minus 3x, we can rewrite it as cosine of 3 theta. Now cosine inverse of cosine of 3 theta means we have y equals to 3 times theta. Now since we have considered x to be equals to cosine theta, this simply means that theta will be equals to cosine inverse of x. So that means in place of theta, we can have y will be equals to 3 times cosine inverse of x. So now we can find out the value of derivative of y with respect to x, which is the same as 3 times derivative with respect to x of the inverse cosine function. Now this is again our standard formula, which will be minus 1 over square root of 1 minus x squared. So we can have negative 3 divided by square root of 1 minus x squared. So this is going to be the derivative of our function y, which is given by cosine inverse of 4x cubed minus 3x with respect to x. Let's move on to the third problem. So here we have to find the differentiation of the inverse tangent of 3x minus x cubed divided by 1 minus 3x squared with respect to x. So we will begin by supposing y to be equals to tangent inverse of 3x minus x cubed divided by 1 minus 3x squared. Or simply put, if we take the tangent on both sides, we'll have tangent of y equals to 3x minus x cubed divided by 1 minus 3x squared. So here we'll make a trigonometric transformation here. We will suppose that x to be equals to tangent of theta. When you consider x to be equals to tangent of theta, then we have tangent of y will be equals to 3 times tangent of theta minus tangent cubed theta divided by 1 minus 3 times tangent squared theta. Now 3 times tangent of theta minus tan cubed theta over 1 minus 3 tan squared theta. This is a trigonometric identity, which is the expansion of tangent of 3 theta. So that means we have tangent of y equals to tangent of 3 theta. So that means we can have y equals to 3 theta. Now since we have considered x to be equals to tangent of theta, this would mean that theta will be equals to the inverse tangent of x. So we can replace this value in place of theta to get y equals to 3 times tangent inverse of x. Now we'll take the derivative on both sides with respect to x. So we have dy over dx equals to 3 times derivative with respect to x of the inverse tangent function. So the derivative of the inverse tangent function, that's a standard value with 1 over 1 plus x squared. So you have 3 multiplied to the numerator 1. So this is going to be the value of the derivative of the inverse tangent of 3x minus x cubed divided by 1 minus 3x squared with respect to x. Now let's move on to the next problem. So we have to differentiate sine inverse of 2x over 1 plus x squared with respect to x. So let's begin by supposing y to be equals to sine inverse of 2x divided by 1 plus x squared. So here we're going to make a trigonometric substitution. We will consider x to be equals to tangent of theta. The x equals to tangent of theta is going to give us, so we have 2x over 1 plus x squared. So this will become equals to 2 times tangent of theta divided by 1 plus tangent squared theta. Now 1 plus tangent squared theta, we know that's a trigonometric identity which equals to secant squared theta. So that means we can replace 1 plus tangent squared theta with secant squared theta, which will be equals to 2 times. So we have tangent of theta, which can be also expressed as the ratio of sine over cosine, multiplied to, we have 1 over secant squared theta. When it goes to the numerator, it will be simply cosine squared theta. So that gives us 2 times sine theta times cosine theta, because 1 cosine theta from the denominator and 1 from the numerator goes away. However, we know that 2 times sine theta times cosine theta, so that's a trigonometric identity with the value sine of 2 theta. So that means in place of 2 times sine theta cosine theta, we can have 2 times it's sine of 2 theta. That means our function y can now be represented as y equals to sine inverse of sine of 2 theta. Right. We know the sine inverse of sine of 2 theta will be simply equals to 2 theta, and we have considered x to be equals to the inverse tangent, x to be equals to tangent of theta, such that theta will be equals to tangent inverse of x. So that means y will be equals to 2 times tangent inverse of x. So this is the value of y. Now when we take the derivative of y with respect to x, so that will be simply equals to 2 times derivative of the inverse tangent function, which is simply 1 over 1 plus x squared. And we have 2 multiplied to the numerator. So that means our final answer will be 2 divided by 1 plus x squared. So let me write it down. So this derivative value will be 2 divided by 1 plus x squared. Let's move on to the next problem. We'll have to find the derivative of the inverse cosine of 1 minus x squared divided by 1 plus x squared with respect to x. So we will suppose y to be equals to cosine inverse of 1 minus x squared divided by 1 plus x squared. So here we are going to suppose that x to be equals to tangent of theta, such that 1 minus x squared divided by 1 plus x squared, that this becomes equivalent to 1 minus tangent squared theta divided by 1 plus tangent squared theta. So we know 1 plus tangent squared theta, that's our identity of secant squared theta. So we have 1 minus tangent squared theta divided by secant squared theta, which will be equals to 1 over secant squared theta minus tangent squared theta divided by secant squared theta. The 1 over secant squared theta, that's cosine squared theta, and tangent squared theta over secant squared theta, that's sine squared theta. Now cosine squared theta minus sine squared theta, this is an identity of cosine 2 theta. So that means when we have cosine of 2 theta, this will become equals to cosine squared theta minus sine squared theta. So that means our function y will become cosine inverse of cosine of 2 theta, which gives us y equals to 2 times theta. And since we have considered x to be equals to tangent of theta, so this will mean that theta will be tangent inverse of x. And finally, when we take the derivative, so let's start. We have y equals to 2 times tangent inverse of x. So the derivative of y with respect to x will be simply equals to 2 divided by 1 plus x squared. So this is the value. Let's move on to the final problem. So here we have tangent inverse of 2x over 1 minus x squared. We will consider y to be equals to inverse tangent of 2x divided by 1 minus x squared. So here we're going to make the trigonometric substitution x to be equals to tangent of theta such that 2x divided by 1 minus x squared, so this becomes equals to, we have 2 times tangent of theta divided by 1 minus tangent squared theta. Now 2 times tangent of theta divided by 1 minus tangent squared theta, this is actually tangent of 2 theta. So here what we have done, we have made use of the fact that tangent of A plus B, that's equals to tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. So in our case, if we consider A to be equals to B and B to be equals to theta, then when we replace in place of A and B with theta, we will get this particular expression. Now we have y equals to tangent inverse of tangent of 2 theta. So that means y will be equals to 2 times theta. So since we have considered x to be equals to tangent of theta, so that implies theta will be equals to tangent inverse of x. As such, y will be equal to 2 times tangent inverse of x, and therefore when we take the derivative of y with respect to x, so that's the same as taking the derivative of 2 times derivative with respect to x of the inverse tangent function. So that gives us dy over dx equals to 2 multiplied to 1 over 1 plus x squared. So this is the derivative of the inverse tangent function. Therefore finally we can say the derivative with respect to x of inverse tangent of 2x over 1 minus x squared, so this will be equals to 2 divided by 1 plus x squared.